Digital subscriber line technology has been deployed for over a decade, but every year it seems to reach greater distances and require more bandwidth. Huawei, a leader in the DSL industry, plays an active role in contributing DSL technologies, research, and development. I'm here today with Dr. Guozhu Long of Huawei Technologies. Dr. Long, there's a lot of talk about digital subscriber line variants like vectoring and Giga DSL that extend the lifetime of copper networks. What's Huawei's view, and how significant will this be to meet customer demands?
DSL has been in service in the last decade. The copper loop has been there for over 30 years, and now the copper is facing the fierce competition from fiber and other media. So DSL has to evolve to new technologies to compete better with other services. In the last decades or so, we see that the DSL is evolving from a few 100K to 100 meg right now. It's all the basic trend is to reduce the loop lengths. With shorter copper loops, then you get better performance, and also you apply for some new technologies to reduce the crosstalk, to reduce the impact from the noise, to get a better performance. So this makes the copper technology better to be competing with other technologies.
Huawei announced that it successfully launched the industry's first Giga DSL prototype. Could you tell me more about that?
This Gigabit DSL is a technology prototype for applications we call FTTP, and currently ITU is working on a new standard called G.fast, and right now it will take probably another year to complete. So we developed this technology prototype to do research, to prove a concept, to verify the new technologies as candidates for the new standard. So far we can we reached up to 1 gigabit per second at 100 meters or lower, and 500 megabit per second at 200 meters. Which is the maximum length required by G.fast. It shows a very promising future for the G.fast.
Operators' copper-based networks vary considerably. What are the keys to successfully upgrading DSL networks to higher speeds, and what are some pitfalls to avoid?
Yeah, we did meet a lot of operators, which are our customers. They do have different requirements, and so we as an equipment vendor has to meet all these requirements with our flexible product lines. And with DSL, it's competing with fiber and other things. The main advantage is low cost. So for any new technology, for copper, it has to be low cost. Otherwise, people may not do to use copper, may switch to other more advanced media like a fiber. So the low cost is the key. And for different deployment environment, the network is different. So the low cost is for all the applications. For example, a new technology called vectoring. You have to cancel crosstalk. The one issue is the complexity will be higher. Sometimes the vector size will be a few hundred lines, so the computation is very complex. So how to implement these things at the very minimum additional cost is the key to the success. And even this vector size is different for different operators. Some are small, some are big. So we as an equipment vendor has to define efficient architecture for our product to fit all the customers' need. For G.fast, it's similar, but slightly different issues. G.fast is for very short loops, so the current idea is to expand the frequency bandwidth. With expanded bandwidth, then of course the complexity becomes higher, including digital and analog front end. So for G.fast, how to do it efficiently at low cost, then we need to define a good standard, use appropriate techniques to reduce the implementation complexity to keep low cost. For example, in our Gigabit DSL, we use a technology called TDD, which is already agreed by the G.fast standard at ITU. And this will reduce the complexity in the implementation compared to the FDD, which is used by ADSL or VDSL2.
Thank you, Dr. Lung, for joining us today.
My pleasure.